Okay, so first thing we would want to do here, of course, is draw our radii to our tangents to get right angles there. Then what could we do? From here to there, go up to here. Okay. If we run that across there, do we know any of the dimensions of that triangle? No, we don't. We have to have at least one side and then either one angle or a second side. The only triangle that we have that information on right now is that one. This across here would be 100 millimeters. How would I get that? Yes, is 60 squared plus 80 squared equals c squared. So we get 100 millimeters there. This angle here would be inverse tangent to 60 over 80. So 36.87 degrees. Now that gives us what we need to find this angle. That angle is going to be 53.13 degrees. How'd we get that? Perfect, the complement of the 3687. Now, if I connect this across here, we have a triangle where we have two sides and an angle. We have the 100 millimeter side, but we also have 50 millimeters and we have the 53.13 degrees. Do we have is this a right triangle? Say no. No. There is no right angle in it. It's an oblique triangle, which means we're dealing with law of sines or law of cosines. Do we have a side in the opposite angle? No. So that means we're to the law of cosines. So I'm looking for this side up here. That side squared is going to equal 50 squared plus 100 squared minus 2 times 50 times 100 times the cosine of 53.13 degrees. Notice I put in the square root right away, so this all gets square rooted. I get 80.62. So this here is 80.62 millimeters. Now that I have that, I can find some other angles. For example, let's find, now that's actually the bigger angle, isn't it? We want to find this angle over here. So we've got the 80.62 over sine of 53.13. That's going to equal 50 over the sine of that angle we're looking for. So cross multiply and divide. That gives us the sine of that angle is 0.4962. Inverse sine of that, 29.75 degrees. Which means this over here is 97.12 degrees. Does that look right? What's that? Yeah, it does get tight, doesn't it? So we now have all three angles and all three sides for that triangle. Next, we can move up to this one. And we can move up to that one because we have a right angle and we have two sides. This is a radius that's still 50 millimeters. This here is 80.62. We can find x because x squared plus 50 squared is going to equal 80.62 squared. The 80.62 is the hypotenuse. So I'm going to do the square root of 80.62 squared minus 50 squared. 63.24. We just found x. A, that angle there. Well, if we knew this angle, we could find angle A. That angle is going to use the opposite side in the hypotenuse, which is sine. So that angle is the inverse sine of 50 over 80.62. .33, which makes this angle here 51.67 degrees. So angle A is the 38.33 that we just found, plus the 29.75, plus this was 36.87. That makes this one up here 53.13. So we add those all up. We get 121.21 degrees. Is that look great? So we have x and we have the angle. Now it's time for us to find some areas. Well, we have three areas that are relatively easy to find. 1, 2, 3. So let's find those areas. Area 1 is just, you got 80 times 60, of course it's divided by 2 because it's a triangle, 2,400. Triangle 2, 50 times 63.24 divided by 2. 1581. 3 is pi times 50 squared to be the whole circle. But we need to know this angle here first. We've got 97 and 51.67 here. We add those up, that gives us 148.79. Subtract that from 360. That gives us 211.21 degrees here. So that'd be 211.21 over 360. Which is giving us 4605.55. Now we have this last little triangle in here. This little triangle here does not have a right angle in it. We could add the sides together and use Hero's formula from last semester. Remember, you find the perimeter, then you cut it in half, get the semi-perimeter, and that's ugly and unfriendly. And Well, let's face it, unwanted. But let's take a look at that triangle. We had 100 millimeters here, 50 millimeters here. This angle right here was 53.13 degrees. If I make an altitude right here, the area would be 100 times that altitude divided by 2. Well, that altitude, if I call that, let's just call it A for altitude, sine of 53.13 degrees equals A over 50, because 50 would be the hypotenuse of this triangle now. So A is equal to 50 times the sine of 53.13. So that area for is 100 times 50 times the sine of 53.13 over 2. Before I calculate that, that actually is an area formula that is used whenever you have a triangle where you have two sides and the angle in between them. The area can always be found by multiplying the two sides times the sine of the angle and dividing by 2. $19.99, no, actually 2000 was rounds to if you go 2 digits, doesn't it? To an even 2000. So I got 10,586.55 millimeters squared. What would that be in centimeters squared? 105.87 probably centimeters squared. We'll stick with that. So either way you wanted to put it, 105.87 centimeters squared or 10,586.55 millimeters squared. Either one of those is acceptable. What do you think? Like I said, it's a matter of finding, you need first of all right triangles if you can, but then you need triangles where you know the right angle. You need to know at least 3 things of it, and at least one of them has to be a side. So if you know the right angle, you have to know at least one side, then either another angle or another side. If you don't have a right angle, well, then you have to have at least one side, and then from there, 2 other pieces of it. Well, for your calculating pleasure, let's say that this is 200 millimeters here. We're going to call this 50 millimeters, 80 millimeters. We're going to say the width of this channel, we're going to go at 60 millimeters. The depth of this channel, let's go 20 millimeters. I want you to find if the density of the block of the material is 48 grams per cubic centimeter. Find the mass of the block. Now, of course, to find mass from density, you need to know the volume. Mass is equal to density times volume, or volume times density. So this is kind of a sneaky way of asking you to find the volume. So I will give you some time there. I realize I didn't give you enough time to do it, but before we run out of time, bless you, let's make sure you're heading in the right direction. Bless you again. So we're going to start out by completing that circle. And we're going to draw this in here. This is 30, 30, 20, and x. We know that 30 times 30 equals 20 times x, which gives us 900 equals 20x, or 45 equals x. Which means for that circle, the diameter is 65. Because 45 to here, you got to add the 20. The radius is 32.5. Of course, that's millimeters. So let's find the area of that segment of the circle. I'm going to redraw it a little bit bigger over here. We know this is 32.5. We know this piece is 30. I can find that angle there. That angle is going to be the big one. That angle, we have opposite hypotenuse, is going to be the inverse sine of 30 over 32.5. 67.38. Oh, sure. Yeah, 3 over, yeah. So 67.38. That makes this also 67.38, which makes that whole angle 134.76. So that means first thing we're going to find is the area of the sector. The area of that sector is pi times 32.5 squared times 134.76 over 360. $1241.52. Millimeters squared. Now we need the area of this triangle. To do that, have to have this length here, which is going to be the square root of 32.5 squared minus 30 squared. That's just a squared plus b squared equals c squared, but we're working it backwards. Got 12.5 there. So the area of that triangle is 60 times 12.5 divided by 2. So is that 375? Does that look right? So then we subtract. Yeah, that looks right. 866.52. That is this area right here. Now remember when we did volumes, we said volume was an area times a distance. So we're going to find this area right here, which is going to be the 50 times 200 millimeters, otherwise known as 10,000 millimeters squared, right? Minus the 866.52 millimeters squared, which is 9,133.48 millimeters squared. $10,000 minus 866. Something's, yeah, it's got to be the 9,000. And we're going to multiply that by 80. Well, you're looking at volume, not area. You got to subtract it from the area, not from the volume. Yeah, that's a volume. 200 times 50 is the area. This is an area. So you got to subtract that from the area to get the area of the surface. Once you have the area of that surface, then you multiply it by the 80 to get the volume. And you could have taken this times 80 to make it a volume if you wanted to and subtracted that. You get 730,000. Is that right? Yeah, that's right. Holy crap. 730,678.4. That is millimeters cubed. Before I can multiply that by the 48, what do I have to do? Because that's 48 grams per cubic centimeter. 3 spots because it's cubed, right? So it's 730.68 cubic centimeters times 48 grams per cubic centimeter. Cubic centimeters cancel out. That's what I get, 35,072.56. 35,073 grams, which is 35.07 kilograms. Still a pretty heavy block. What do you think? There you go. Divide by 2. No, wait, you're right, times 2.2, so 77 pounds. That's hefty, yes. That'll keep you grunting a bit. Well, this shouldn't be a shock. I have a worksheet for you for homework. I'll pass that out. Tomorrow will be our final quiz on this stuff. Then we'll move on to compound angles.